are finishing the new grounding to the house. So what that means is before he had very little for grounding on the house. He had like a steel rod in the ground, which didn't really equate to anything. Right now he's going to have 2 8-foot ground rods that go straight into the earth, and he's going to also have some new grounding to his water piping in his house, and so on and so forth. So he's going to be all brought up to code by the time we're done with this, and a lot safer too, for if he does have any future strikes like he did have. Yeah, I don't know why he keeps doing
that. This is just some existing disconnects he had for a compressor and I'm assuming a welding outlet. Just putting it back in, powering it back up. Right, Jer?
Nope.
This, we gotta check the specs on that welder.
I need a sip of coffee too. Because of the surge that came through, all of his appliances are actually all fried. Dishwasher, oven, range, refrigerator, they all got fried during the surge that came through his house. So what we're gonna do today is we're gonna go through every outlet. Since there was high voltage that went through every single outlet, exceeded the rating factor on the outlets and blew apart splices. We're gonna go ahead and change all the outlets and switches and everything else in the house today. What's that?
Don't want to burn up.
So the reason outlets and switches go bad is because of what these are called. These are called backstab. Instead of hooking the screw around, or the wire around the screw like this here, a lot of years previous they backstab the outlets. What happens after time is they loosen up and the wire becomes loose, and it actually pulls out of the back of the outlet, causing things to short out, surges, and possible house fires. So that's one thing that we look for when we pull out old outlets. If you have a bunch of backstabbed outlets, it's a serious problem. See, I mean, you could see how, you know, it just pulls out. There's nothing holding it. And this is a newer outlet. I mean, some people have only 2 prongs, and those are very old. This has been upgraded since, but in essence, it's still backstabbed, so it's still a problem. You know?
Oh, this one here?
So we can see a couple things wrong here just before we even open this up. This is a standard outlet. It's next to the sink in a bathroom. There should be a GFI protected outlet. What that means is it should have the button, test and reset button on it, just for being near water and to follow today's codes. Yeah, so this is a old backstab outlet. You can see there's no screw terminals on it, and everything is just you know, it's backstabbed in there. See, it just pulls right out. You know, so very dangerous stuff. Should be replaced. Very old. Like I said, this has has 3 prongs and it's still backstabbed, which will be no longer. We're going to put a new GFI in there, hook all the terminals, redo the box, make it look nice, and you'll be all set.
So
this is what we call BX cable. It's a metal cable, armored cable that has 2 conductors in it. All the new homes now is what they call Romex cable that have 3 conductors. So being that in these older homes, years ago they used to put the old devices in and there would never be a ground wire or a safety wire connected to all the devices. So what we're going to do is we're going to add one to the box, stick it into the box, and because the metal cable is the grounding conductor, we're going to stick this in the box. That'll make a nice connection and it'll give the device a ground terminal, and we'll show you how that's done here. So screw it in the box here. Alright, one for each device if you can. If not, you could make a little splice in there. Lengthen this wire, it's a little short. When people ask how much work goes into a box that's existing and doing it right, nobody could ever guess how much time is involved in just doing things right in a single box, but this is what it is. So we talked about backstabbing last time. Well, now what we do is, since that is no longer an option in our eyes, we're going to hook everything so everything's hooked around the terminals. So everything is hooked, making a good connection. And then you have your ground wire, which every new device has a ground screw. It's pretty simple, green to green, and you'll have a ground to all your devices. I'm no Bob Vila here. We're getting videoed, so I'm a little nervous, so so we'll go for it here. We use green tape because that's all I had in my pouch, so that's what we get. But we use the tape to, just you're sticking a device into a metal box, and just so the screws don't hit on the metal of the box, we always tape our devices. So this is the GFI. This is what was there before, prior, and this is what we're putting in. This is a GFI. This meets all criteria and codes next to a sink in a bathroom. And you're going to ask me why I'm going to backstab these. Well, this is by manufacturer specs. These are not backstabs. They actually tighten down on the wire themselves when you stick them inside the terminal blocks. So this is not a backstab. This is what the manufacturer calls for. So if you ask why I'm backstabbing this one, that's the reason why. So simple as that. Tighten down on the screw. Alright, and then this is But as you can see, it's not a backstab. It's not pushing against some kind of spring actuated mechanism. It's just tightening the wire, so there's no way that's gonna ever pull out. And what we're gonna do is tape this up. Again, if people want to ask why it takes so long for one box, this is the only way to do it right. So it takes some time, that's all. So, this plate's cracked.
Oh.
You don't want to use that one. So these wires are awfully short to try to get onto a new device. So what I'm going to do is I'm going to splice all these wires together, the whites and the blacks, with a pigtail, so it's easier to work on in the future, and it's one just gives me a little more wire to be able to make happen. Again, we got the green wire, you know, like I was showing you on the other video. This is what we call metal or BX cable, so we add the ground in every box to make it a little more safe and up to date as much as possible as we can. As you can see, just splicing the wires together is very tough because they're so short. So imagine trying to get them around a device to make them make a good connection. It's almost impossible. I'm gonna turn the heat back on. You don't want me to get whacked?
Yeah.
Come on.
I don't remember exactly which one it was.
If it was you, I would have just cranked it on. No, yeah, go ahead. So what we're doing is making everything splice, so all we have left is these two wires. Doing it the other way would have been fine if they were a little longer. It would have had a little more movement to be able to, you know, get at the outlet. But now we could put the outlet on, have plenty of wire. If you ever want to pull the outlet out later, you're good to go with that too. So works out best for you. Try and make it easy to service later too. Probably 90% of the outlets in New England and the older homes are exactly what you see here. So again, you know, I spliced all the whites, all the blacks. The whites are always on the side with the green screw. Very simple to use, very simple to connect. So the green goes on the green screw, the whites go right next to it. It's always going to be that way. And there's a few different scenarios, but most of the common connections, that's what you're gonna have. What I do is I screw this extra screw in just so when it doesn't hit the box, if it ever moved the outlet. And what I do is I flip it around, then your black goes on the complete opposite side. Justin, we're giving a little tutorial here.
Yeah?
Yeah.
How to mess stuff up?
Yeah. Then use the green tape instead of black, you know?
Yeah.
I like to be different.
Any tape is good.
So that's the outlet. It's all taped up, ready to go in. You know, again, we tape it up so it doesn't hit on the metal of the box. And it's a safe connection. After a while, outlets can loosen up just from use. So when the outlet loosens up, it could have a tendency to slide side to side and maybe bang against the box, causing the outlet to short out. So we just tape it, just for safety purposes. If you notice, this is a child-proof outlet too, which is code for today's standards. So if I try to stick my screwdriver in, if I was a kid, took a safety pin, tried to stick it in the outlet, you're not going to get shocked. There's no way I could touch the connections inside by sticking anything in there. You'd have to be a brainchild and stick two things in at both times in both sockets to make it a connection, which that would probably never happen. But so yeah, a childproof. You know, this could be live right now, and I would never get electrocuted. This is what a childproof outlet is. And that's standard with any outlet going in somebody's house today.